So today we have an easy geometrical problem. We take a quarter circle and label its 3 points as P, Q, R, where P is the center of this quarter circle. Now we inscribe a square inside this quarter circle and label its corner as A, B, C, D. Now there are two things that specify the position of this square. The first thing is that the point C lies on the circumference of this quarter circle, and the second thing is that the length of the line segment AP equals to the length of the line segment BR. Now we inscribe a semicircle inside this quarter circle such that the point Q and the point S are the endpoints of its diameter, and the point D lies on the circumference of this semicircle, and this is the thing that specifies the position of this semicircle. Now the question is, what fraction is shaded? In simple words, you have to find the ratio of area of this semicircle upon area of this quarter circle. So now let us see the solution. How can we find this particular ratio? So first of all, we will take the radius of this quarter circle as a variable capital R and the radius of the semicircle as small r. Now we will take the length of the line segment PA equals to BR equals to small a. Now we will take the side length of the square as a variable B. Now there is a nice relation formed over here, that is the length of the line segment PA plus AB plus BR equals to PR. Now the length of the line segment PA equals to A plus the length of the line segment AB equals to B plus the length of the line segment BR is again equals to A, and this thing is equals to PR, that is ultimately the radius of this quarter circle, and we have taken it as a variable capital R. Now if we will isolate A on one of the side, we will get its value as R minus B upon 2. So here we have got A in the terms of R and B, so let us replace this in the original question. Okay, so here we have replaced A with its value, that is R minus B upon 2. Now we will join a line segment from the point P to the point C, and if you observe this line segment carefully, it is running from the center to the boundary, forming the radius of this quarter circle. This means that the length of this line segment equals to capital R. Now the length of the line segment BC is equals to the side of the square, and we have taken it as a variable B, and the angle B is 90 degree because it is the corner of the square. Now look in this triangle PCB, which is a right angle triangle 90 degree at P. In this triangle we can simply apply the Pythagoras theorem. So as per the Pythagoras theorem, base square, that is PB square, plus height square, that is BC square, equals to hypotenuse square, that is BC square. Now the length of PB equals to PA plus AB, that is R minus B upon 2 plus B the whole square plus the side square, that is equals to B square, and this thing is equals to hypotenuse square, that is capital R the whole square. And when you will simplify this equation, you will get B equals to 3 times R upon 5. Now remember that A was having a value capital R minus B upon 2, so this new value of B can be just put it over here so as to get A equals to R upon 5. Okay, so till now we have got A in the terms of R, that is A equals to R upon 5. B in terms of R, that is 3 times R upon 5. Now we will try to get small r in the terms of capital R. So for that we will draw two line segments. The first one is just very simple, extend the line segment CD to meet the line segment PQ. And the second is draw a line segment from the point O to D. Now the point where DC intersect with PQ, we will name it as point M. Now this angle at point M would be 90 degree because we have extended DC as a straight line, and angle D was 90 degree. Again angle A was 90 degree because they are the corners of the square, and angle P equals to 90 degree because it is the center angle for this quarter circle. Now observe the quadrilateral PADM. It is a rectangle because all the corner angles are 90 degree, and in a rectangle opposite sides are equal. Therefore the length of the line segment PM equals to the length of the line segment AD, and AD is the side of the square that was equals to B, and we have already found the value of B in terms of R, that is B equals to 3 times R upon 5. And similarly we have that length of the line segment PA equals to length of the line segment MD. PA is having a length R upon 5, therefore MD would also have a length R upon 5. Now what can you say about the length of the line segment OM? So we can get its length using this method, that is the length of the line segment PM plus the length of the line segment OM plus the length of the line segment OQ equals to the length of the line segment PQ. Now PM is having a length 3 times r upon phi plus OM length as it is, because this is the thing that we have to know, plus the length of OQ, that is equals to small r, and this thing is equals to PQ, that is the radius of the quarter circle that is having a length capital R. And when you will simplify this particular thing, you will get that OM equals to 2 times capital R upon phi minus small r. And now the line segment OD is from the center of the semicircle to the circumference, so it is equals to the radius of the semicircle, that is equals to small r. Okay, so now we will take the right angle triangle OMD, that is 90 degree at angle M, and apply the Pythagoras theorem in it. So the base square, that is r upon phi the whole square, plus the height square, that is 2 times capital R upon phi minus small r the whole square, would be equals to hypotenuse square, that is small r the whole square. And when you will simplify this particular equation, you will get that capital R is equals to 4 times the small r. So here we have got the value of capital R in the terms of small r. Okay, so as I told you before, that if we are solving a question in which you have to find a particular ratio, so you have to get both of the variables in terms of each other. So we have done that thing over here. So the required ratio was to get area of the semicircle upon area of the quarter circle. Now area of the semicircle is equals to pi small r the whole square upon 2 upon area of the quarter circle, that would be equals to pi capital R the whole square. Now we have capital R in terms of small r, that is 4 times r. So pi into 4 times r the whole square upon 4, because it is a quarter circle. And when you will simplify this thing, you will get 1 upon 8, and that's the answer that we were looking for.